Hello and welcome to this AQA Further Maths Statistics video. The first in a series looking at chi-squared tests, and this time we're looking at constructing contingency tables. If we have a look at the first question posed up here, is there any connection between hair colour and eye colour? Well, this type of data is clearly qualitative. There's nothing we can measure for such data, and it's what's called categorical data. So there's nothing we can measure, but we can categorize eye color and categorize hair color. So how can we investigate whether there is any association between two such variables? And you may have come across the chi-squared test for association, possibly if you study A-level psychology. And it's a very, very important test, and one used in the case of having data that is qualitative, not quantitative. So the first step is to put our categorized qualitative variables into a two-way table or a contingency table. And you can see our contingency table here for our two variables, hair color and eye color, and the categories are black, blonde, brown, red, and it's very common in a contingency table to have an other category, and you can see we have it in both. We need to be able to categorize everybody in our sample so that we can get information from our sample, and here we have a sample of 131 people in total, and not everybody necessarily falls into the obvious categories, so there is an other category in each of those two variables. And also notice that we have a column and a row for totals here, and you may find you're presented with a contingency table, in which case always evaluate the totals, or if you produce one yourself, again always evaluate the totals and check that the totals for your rows and the totals for your columns add up to the same overall grand total. And if we have a look at this contingency table, say in this cell, as we call it, this category there, that's people with brown hair and green eyes, and we had 5 of those in our sample. So sometimes our data may be quantitative, but it could be grouped into categories. So for example, here we have GCSE grades, but we've grouped it into categories 1 to 3, 4 to 6 and 7 to 9. And notice that there must never be any overlap between the categories that you choose for categorizing the information that you've got. And again, notice we've got totals there, and the totals for the rows and the totals for the columns both give us our overall total 83. So there were 83 people involved in our sample, and those people were categorized according to GCSE grade and eye color. When we want to analyze the data we have in a contingency table, the way we do it is to compare two sets of values or frequencies. So first of all, we have our observed value, OI, because there are several of them, and those are the actual frequencies of the data gathered. So the frequencies from our sample that we put in our contingency table. And then we compare those with our expected values or frequencies, and those are what the frequency data would be expected to be if there was no association between the variables. And it's very important to bear that in mind, because this will actually enable us to construct our null hypothesis, because only in the case of no association can we actually evaluate what the expected values should be. Now, in order to find our expected frequencies, our expected values, we must assume no association between our two variables. So what do we mean by that? Well, we mean assuming that the two variables are independent. And that means in terms of how we get an expected value, we can use the rules that we know about probabilities and independent events. So just a quick reminder of a couple of important probability theory points. First of all, if we have experimental probability, so we can only get a probability for an event by looking at what happened in an experiment. So here we have a biased die and we obtained 8 sixes out of the 30 times we rolled it. That would give us a probability of obtaining a 6 estimated as 8 out of 30 from the data that we have. We're then asked how many 6s would be expected in 100 such rolls of this die, and we would just multiply that by 100. This is the probability, therefore out of 100 we'd expect that fraction of 100 to result in a 6. And the second little reminder here is that if A and B are independent events, then the probability that A and B occur is just the product of the two probabilities, the probability of A multiplied by the probability of B. So here we have our contingency table with our observed values, our observed frequencies. How can we work out the expected frequencies, assuming that hair colour and eye colour are independent events? Well, if we just look here, we had 7 people with blue eyes and black hair. How many would we expect if hair colour and eye colour were independent? Well, let's have a look. First of all, what's the probability that a person has blue eyes? Well, we estimate that from the information we've got, and there were 40 out of 131. So our probability would be 40 over 131 for blue eyes. And the probability we would estimate for black hair would be 29 over 131. Therefore, the probability of obtaining somebody with blue eyes and black hair would be the product. It would be 40 over 131 multiplied by 29 over 131. That's our probability. So how many people would we expect to have blue eyes and black hair? Well, that would simply be whatever this particular probability comes to, that fraction of our total 131, and that gives us 8.85. And it's very important at this point to realize these are just expected values. They're theoretical. They're not going to come to integers, and you shouldn't round them to integers. In general, theoretically, we would expect 8.85 people out of 131 to have blue eyes and black hair. And notice that our probability here multiplied by the grand total can be simplified, and you can see that we simply have the row total 40 for blue eyes multiplied by the column total 29 for black hair divided by the grand total, and that's how our expected frequency will be evaluated. And it's worth you having a go at doing a few more. So for example, blue eyes and blonde hair would be 40 multiplied by 22 divided by 131. So quite simple to do, and just make note of the fact that if you need to calculate an expected value or frequency from a contingency table of observed values, you simply evaluate it by multiplying the column total by the row total and dividing by the grand total. And here's the completed table, and it's always worth just doing a bit of a mental arithmetic check, and for example just checking that your top row does indeed still add up to 40, because obviously we've used those totals, so that should still add up to 40, and similarly for the other rows, and that your columns add up to the correct column totals, and that everything still adds up to 131, and it may be slightly different perhaps in the second or third decimal place, but that you've more or less got to the total that we are required to have. And that concludes this first video in the series.